Hi-ho! Let's go! Chapter 11, lesson number 4, Sin2A and Cos2A. If you think about the last few lessons, we've been looking at the addition formulae and using them. If we wanted to work out Sin2A, well, you could write that as sin A plus A. And if you then think about the addition formulae, you could write that, because it's sin something plus something, you could write that as sin cos, cos sin. From there, if you think about it, you've got a sin A and a cos A, and here you've got a sin A cos A, so really you've got two sin A cos A. Looking at cos2A, if you want to rewrite that, you could think, well, that is also cos of A plus A. And from there, because you have cos something plus something with your addition formula, you could write that down as cos A, take away sin A, sin A. Or in other words, cos squared A, take away sin squared A. Also, if you think back to many years ago when we were looking at trig identities, you know cos squared plus sin squared is equal to 1. And you could rewrite that, so you could say sin squared is equal to 1 minus cos squared. And cos squared is going to be 1 minus sin squared. So rather than saying this is cos squared A take away sin squared A, well, you could rewrite sin squared in terms of cos and say that's 1 minus cos squared. From there, if you get rid of the brackets, simplify it, you get 2 cos squared A take away 1. And you could also have said, right, well, I want to rewrite cos squared in terms of sin. So cos squared A is 1 minus sin squared A. So in other words, 1 minus sin squared A take away sin squared. Again, get rid of the brackets, simplify, and that is equal to 1 minus 2 sin squared A. Really, what we get then are these four formulas. We'd have Sin2A is going to be 2 sin A cos A. But for Cos2A, we get three formulas. We get this one, or this one. And depending on the question, will depend on which one you use. Sometimes you can use any of them, and it does not matter. I'll show you some questions in just a second, but if you're super geeky, just like Liam, what you want to do is you maybe want to go a bit further and rearrange some of these equations to get cos squared x or sin squared x or A. But you don't have to. These are not given in the exam, but these ones are, these four just at the top. Let's look at some of the questions then. So, write down a formula for sin 4x. Well, first thing you want to notice is each of these formulas here, it's going to be sin 2 times something. So we have to rewrite sin 4x as sin 2 times something. 2 times what gives you 4x? Well, you know it's 2 times 2x. So once you've got that, instead of sin 2a, we've got sin 2x. So we're replacing the a with 2x. So in this formula on the right-hand side, replace the a with 2x. And we end up with this. Next question, cos 10x. Again, you want to rewrite that as cos 2 times something. So 2 times what gives you 10x? Well, you know that's going to be 5x. So you'd have cos 2 times 5x, and again, thinking about it, you're replacing the a with 5x. That's what you're multiplying the 2 by. So you can replace the a with 5x here. So doing that, you will end up with cos squared 5x. Take away sin squared 5x. We could also have used this formula here, again replacing the a with 5x, and we've got 2 cos squared 5x, take away 1. Or you could have used the one at the bottom, so you'd have 1 minus 2 sin squared 5x. Example 2. Simplify 2 sin pi over 12 cos pi over 12. So Hannah, how would you do this? Brilliant, you just want to use the formula at the top, so you want to see, look at the right hand side, which one is this very similar to? Well, you'll notice that if you have 2 sin something, cos something, well, that's very similar to this top line here. 2 sin something, cos something. Instead of a, we have pi over 12. So we're just going to write that as the left hand side. The a place the a with pi over 12. So we'd have sin 2 pi over 12. Would we leave it as that, so Hannah? No, we'd go further. Good. If you end up with fraction 2 over 12, you know that's sixths. So you could write that as sin pi over 6. And I'm sure you know that by now. If not, you could just go off, use your exact value triangles, or you may have memorized the table, and you'll know that pi over 6, 180 divided by 6 is 30 degrees. So the sine of 30 degrees is 1/2. and that is simplifying it fully. Example 3. Simplify 2 cos squared pi over 8. Andrew. Oh, and take away 1. Andrew, what would you do? Good. Again, you want to use one of these formulas. Andrew, which one would you use? Good. You want to use this one here, the 2 cos squared a, take away 1, because we have it in the form of 2 cos squared something, take away 1, but we're replacing the a with pi over 8. So write that as your left-hand side, but replace a with pi over 8. So we end up with cos 2 pi over 8. Again, simplify that. Imagine, Andrew, if you have the fraction 2/8, what's that the same as? Quarter. Good. So that's cos pi over 4. Would you leave it as that, Andrew? No. You would go on and you would use your exact value triangles, and you think pi over 4, 180 divided by 4 is 45 degrees. So the cos of 45 adjacent over hypotenuse, and you get 1 over root 2. Next example. Number 4. If sin x equals 3 over root 10 with x between 0 and pi over 2, or 90 degrees, find the exact value of cos x, sin 2x, cos 2x, and sin 4x. So what's the first thing that you need, Muzammil? Triangles! Good, you need the triangles. So if you think about this, you've got sin x equals 3 over root 10. So imagine your right angle triangle where sin is opposite over hypotenuse. So your opposite over hypotenuse would give you the 3 over root 10. So you're going to imagine something like this. So you know the opposite divided by hypotenuse would give you 3 over root 10. What would you have to do after that though, Absar? Good, you want to find the missing side. Absar, what do you think you would get for the missing side? 1. Good. You would end up with 1. Why is that, Absar? What did you use? Pythagoras. Good. Using Pythagoras, you would have root 10 squared, take away 3 squared, which would give you 1, and then square root it to give you 1. From there, you can easily work out the value of cos x. Cos x is going to then end up as 1 over root 10. Good. You're just using this triangle here. Cos is your adjacent over hypotenuse, which is the 1 over root 10. Slightly trickier, sin 2x. How would you go about finding that, Lily? Good, use the formula. So using the formula, you know that sin 2x, you could replace that with sin 2 sin x cos x. So doing that, you can then say, well, you know what sin x is. It's given in the question. That's 3 over root 10. Cos 2x, we just found out. So you can say that's going to be 2 times 3 over root 10 times the 1 over root 10. And from there, if you multiply that out, well, imagine 2 as 2 over 1, so you've got the fractions together. So multiply the numerators, 2 times 3 times 1 is going to give you 6. Root 10 times root 10 is root 100, square root of 100 is 10, so you end up with 6 over 10. Simplify that though, and you get 3/5. So that would be sin 2x. Going further, part C, cos 2x. Well, how would you get cos 2x? Well, from here, you want to use one of the formulas again. It doesn't really matter which one you use. You could use any, and you would get the exact same answer. I'm going to use cos squared x minus sin squared x. So I'm just using this formula here and replacing the a with x. From that then, I know what cos x is, so I can replace that. That was just from that first part that we worked out. We also know what sin squared is. That's given in the question. That's the 3 over root 10. So that'll be take away 3 over root 10 squared. From there, 1 over root 10 squared. We'll square the top, square the bottom, and you'd end up with 1 over 10. You're taking away square the top, square the bottom, and you get 9 over 10. Giving you, well, 1/10 take away 9/10. Well, denominator is the same. 1 take away 9 is -8, so we get -8/10. I'm sure you all know, though, that would become -4/5. Last part with that, sin 4x. Well, first of all, we don't have a formula for sin 4x, so we need to rewrite that. Chelsea, what would that become if you rewrite it? Good. You would have sin 2x. Because you always want it in the form of, well, if it's sin, you want sin 2 times something. So 2 times what gives you the 4x? Well, it's 2 times 2x. So rewriting that then, replace the a with 2x, and you would have sin 2x cos 2x. What you'll notice is that sine 2x was the answer for part B in this. We had to work out sine 2x, which was the 3/5. And the cos 2x was that last answer, the negative 4/5. From there, again, just imagine 2 is 2 over 1, so work out 2 times 3 times 4. Work out 1 times 5 times 5. The answer will be negative, and you get negative 24 over 25. Example 5. If tan theta equals 1/4, where theta is an acute angle, calculate the exact value of cos 2 theta. Now, what's the first thing that you want to think about here, Connor? What do you always think? Good, the triangles. If you're given tan theta or sine theta or cos theta equals and then a fraction, just draw a right angle triangle, and then so you know tan is opposite over adjacent, so you know the opposite will be 1 and the 4 will be 4. So you can get that 1 over 4. From there, what would you then do next, Connor? Good, work out the missing side. Using Pythagoras, well, 4 squared plus 1 squared will give you 17, so this missing side will be root 17. From there, we do want cos 2 theta. So cos 2 theta, which formula do we want to use this time? Well, it doesn't really matter, because we could work out cos x, we could work out sine x, so we could work out sine squared and cos squared easily, so it doesn't matter which one you use. I'm going to use 2 cos squared theta, take away 1. So using this formula here, I'm replacing the a with theta. From there then, you know that cos squared theta means cos theta squared. So cos is the adjacent over hypotenuse, so that'll be 4 over root 17. So you end up with 2 times 4 over root 17 squared, take away 1. If you square 4 over root 17, well, 4 squared is going to give you 16. Root 17 squared will just give you 17. So we'd end up with 2 times 16 over 17, take away 1, which means that will become 32 over 17. Take away, well, really to subtract, when you've got fractions, you want to imagine the 1 as a fraction. So 1 can also be written as 17 over 17. Doing that then, now the denominator is the same, just subtract the numerator and you would get 15 over 17. Example 6. Prove that sine A plus cos A all squared equals 1 plus sine 2A. So for this, we're wanting to start with the left-hand side, sine A plus cos A all squared. Don't write that down. Don't say that it equals 1 plus sine 2A. That's what we want to prove. So we want to go through this, and this here should be our answer, this right-hand side. So the first thing you want to think is if you've got something plus something all squared, you know you're just going to have your double brackets and then you'll want to multiply them out. So you'd have sine A plus cos A times sine A plus cos A. Multiply that out. So we've got sine A times sine A, which will give us sine squared A. We'd have a sine A times cos A. We'd have another sine A times cos A. And we'd have cos A times cos A, which is cos squared A. From there, we've got a sine squared and a cos squared. And we've also got a sine A cos A and another sine A cos A. So we're spoilt here. We've got 2 sine A cos A's. From that, do you remember what sine squared A plus cos squared A is equal to, Leah? Yeah, it's just equal to 1. And if you have 2 sine A cos A, I suppose you could leave it as that, wouldn't you? No, you wouldn't, because you know, looking at the formula at the top, 2 sine A cos A is equal to sine 2A. So you can write that as sine 2A. And once you've done that, just look back to the question. We were asked to prove that that's what it's equal to, and that is what we end up with. And we were just showing all the steps in between. Last example, number 7. Using 3A equals 2A plus A, prove that sine 3A equals 3 sine A minus 4 sine cubed A. So the first thing you want to think is we're wanting to prove that sine 3A equals this right-hand side. So that is what we're starting with. And you know that we're replacing the 3A with 2A plus A. If you do that then, we've got sine something plus something. So with the addition formula from lessons 1 and 2 and 3 in this chapter, you can write that as sine 2A cos A plus cos 2A sine A. From there, well, if you look at it, we've got a sine 2A and we've also got a cos 2A. So what we want to do is we want to use the formulas here for that. And we want to replace the sine 2A. Well, we can only replace it with 2 sine A cos A. So doing that then, we'd replace that with 2 sin A cos A times cos A. We also want to replace the cos2A. Again, there's a choice of 3 formulas here. Which one would you use? Well, if you look at our answer is only in terms of sine. So we are far better to replace cos2A with the one that's only in terms of sine, which will be this one here. So replace cos2A with the 1 minus 2 sine squared A. And obviously then we're multiplying by sine A. If you do that, you could then multiply out the brackets. So 2 sin A cos A will become 2 sin A cos squared A. Plus, if you multiply 1 by sin A, we just have sin A. And then we'd have minus 2 sin cubed A, because we have sin squared A times sin A. From there then, well, where would you go next? What do you think you would do, Sandy? Good. We want to replace this cos squared A. So replacing cos squared A, again looking at the answer that we're wanting, it's only in terms of sine. So we want to replace anything that's in terms of cos. Sandy is perfectly right. Cos squared, Sandy, is equal to 1 minus sine squared. Good. So we can write that then as 2 sin A brackets 1 minus sine squared plus the sin A, that's staying there, minus the 2 sin cubed A, which is also staying there. From there, multiply out the brackets. So we've got 2 sin A times 1. We'd have 2 sin A times sine squared A, which is 2 sin cubed A, plus sin A minus 2 sin cubed A. From there then, well, we've got 2 sin A plus sin A. So that means we've got 3 sin A's. We're taking away 2 sin cubed A, and then we're taking away another 2 sin cubed A. So we're now missing 4 sin cubed A. And that is our right-hand side. So we're asked to prove that sin 3A equals that right-hand side there, which is what we have done. We've just shown all the steps in between. Obviously, this is a hard example. This would be an A-level question. It's something to go back to in your own time. Maybe go back to this in a week, 2 weeks, a month. Try it, see how you get on. Try some of these questions though in the book. It is the Maths in Action, page 158, exercise 4A, formulas for sin 2A and cos 2A. In other words, your double angle formulae. Enjoy!